recording of this session. And what kind of problems do you have for us to look at tonight?
Let me go get my binder.
Okay. Like everyone else, you're working on factoring quadratics.
Yep. So we have questions that are like, we're supposed to factor them completely, and an example would be, let's find 24x squared y minus 40xy.
Okay. First thing we want to do when we're going to factor something is see if there is a greatest common factor. In other words, is there a number? What's the greatest common factor for a number?
For this one, I have 8xy. That goes into all of them.
Good. What's left?
3x minus 5.
Okay. What's the next one? When you know them that well, I won't spend a whole lot of time on them.
Yeah, that was one of the easier ones. I'm looking for one of the ones I had trouble with.
Okay.
Oh yeah, xy cubed minus 2xy squared plus xy.
Okay. Let's look at one variable at a time. First of all, are there any numbers we can factor out?
xy.
Right. I mean, there's no numbers. We can't factor out a 2.
No.
So, but we can factor out an x, and we can factor out a y. Once you've factored those out, what's left is if you divide each term by xy, you'll get what we need to write. So what does that equal to?
It would be y squared minus 2y plus 1.
Correct. Now, is that fully factored?
No.
Because we can factor this into what?
We could have xy and then in parentheses y minus 1 and then y minus 1 again.
Okay. So far, so good. How about a standard like that? In other words, a quadratic that doesn't have any greatest common factors. I can't pull any greatest common factors out of that. So the only way I can factor that is something times something else. Do you know how to factor these?
Since both the first set of numbers and the last set are can both be square rooted equally, we could do x. X.
I have kind of a technique for doing these. Let me explain it. So we start with that. We know that the first two terms have to be x because x times x is going to give us our x squared term.
Yeah.
Next thing we want to look at is the sign on the constant. Because that is negative, that means these signs have to be opposite. Plus minus or minus plus. And as long as the coefficients of the x term are the same, plus minus is the same as minus plus.
Mm-hmm.
So now what's the next step?
We could do x plus 3 and x minus 2.
Right. In other words, the next step is we want factors of 6 that subtract to the coefficient of the middle term, 1. So the factors of 6 are 3 and 2. They subtract to 1. We put the larger factor with the sign of the middle term. So the 3 goes there, the 2 goes there. Now I check it to make sure it's right. I got 2x there. I got minus 3x there. Add that together. There's your middle term. It works. It's correct. Okay. So it looks like you're pretty good at factoring those also. So what else do you have that you're having trouble with?
We can do 4hk squared plus 16h squared k.
Now these are all problems that have a greatest common factor. So these should, I suspect you can do all of these. What's the greatest common factor?
4hk.
What's left over?
K.
Whoops. Sorry about that.
K plus 4h.
Exactly. Okay. Sounds like the ones you've been working on at this point are all greatest common factor problems.
Yeah, here I'm gonna send you a picture of the worksheet we gave us that of all the different ones that are on the test.
Okay. You have my email address?
No.
No. Here, let me type it on my screen. Go ahead and put it into your smartphone, and then you'll have it in the future. It's 1949. Let me know when you've sent it. I know it takes 15 seconds or so usually for me to get it.
Can you pull your email up again?
Yeah, it should be visible right now.
Yep. All right, I just sent it.
Okay. While we're waiting to get it, give me your email because I need to send you the email to have the link of this recording.
Okay, hold on. I'm plugging my phone up real quick.
Okay.
All right.
What's your email, Jackson?
Jackson Walker, no caps, no space. 18 @gmail.com.
Okay. Let's see if I've
Those
got
J and W's aren't capitalized.
Okay. I actually don't think it matters.
Okay.
I don't think that it's case sensitive on an email address. I've used capital D and capital C for me, and it doesn't seem to matter. So,
Okay.
all right. So here I got your thing. Let me pull that up so we can both see it. All right. All right, let's see. Greatest common factor, same thing. These answers are your answers, or there's notes from the teacher?
No, these are my answers.
Okay. So you understand difference of perfect squares. Number 3 is different. It's not a greatest common factor anymore.
No.
Okay, number 4 is sum of cubes. So you know that one. Number 5 is difference of perfect squares. I might write number 5 as 9 minus 2a times 9 plus 2a. You have the same thing here, but you've just switched them around, which is fine, no problem.
So that order doesn't matter?
No. In other words, minus 2a plus 9 is the same as 9 minus 2a. It's just that when I think of difference of squares, I always start with that number, the square root of that number. So I would have immediately said 9 minus 2a times 9 plus 2a.
Okay.
Okay, so this is greatest common factor, same thing we've been doing. This is difference of squares, 2a minus z times 2a plus z. See how you put the first term as the square root of this term each time? That's a more typical way of doing it. All right, this is x plus 7 squared. This is difference of perfect cubes. You've got that right. This is difference of perfect squares. So u squared minus 2v times u squared plus 2v.
This one I needed help on when I did it at first, and like those marks up there.
On 10?
The teacher's note.
Yeah.
Yeah, on 10.
Let's look at 10 here. In other words, when we have difference of perfect squares, it doesn't always have to be a squared minus b squared. It just has to be something that the square root of is a perfect square. So if I have u to the 4th minus 4v squared, well, the square root of that is u squared. The square root of that is 2v. So there's my a minus b times a plus b. Another way to look at this is use substitution. Let a equal u squared. Let b equal 2v. Now, somebody may not have pointed that method out to you, but it actually makes understanding it a little easier. If you can imagine that we're going to use a substitution of a equals u squared, so this whole thing becomes a squared minus b squared with this substitution. And then, of course, that goes to a minus b times a plus b, which goes to u squared minus 2v times u squared plus 2v. Okay?
Yep.
Good on that one?
Yep.
Let's see what else you got here. 11. That's pretty straightforward. In other words, it's going to be 5y times 5y.
Yeah.
And it ends up being 5y minus 1 times 5y minus 1, or that. So they're giving you a lot of them like this, where you can figure out that it's a perfect square thing.
Mm-hmm.
This is greatest common factor, x, and what you're left with is x squared minus 1, which is difference of perfect squares, giving you this.
Mm-hmm.
This one we did. This one, first step is to factor out the greatest common factor of t, and then you're left with t squared minus 12t plus 36, which becomes t minus 6 squared, so that's pretty straightforward. This one, you factor out greatest common factor, and you're left with something that is infactorable. Yeah, it becomes y squared. I'm not checking the math on here. I presume this is correct. Yeah, it looks like it's correct.
Yeah.
So this is a 2y minus 1.
It's supposed to be a 2y plus 1.
Right, 2y plus 1, which makes it y minus 1 times y minus 1, right?
Yeah.
Okay. And 17. So we're going to factor that we're going to group this. That's what this is called, is grouping.
Yeah.
So once you've grouped those two items, you can factor out an x. And then we do something quite unusual that you're probably not used to doing, which is factoring out a binomial. In other words, when I have this expression, I can factor out that binomial. So I end up with a plus b times x plus 1. So you need to take this one step further. Notice,
Okay.
notice what my answer is compared to yours.
Yeah.
In other words, the tricky part of this is factoring out that a plus b, which is to say you're going to divide this term by a plus b, and you're going to divide this term by a plus b. What you have left is x plus 1. Okay. So again, same thing here. You're factoring out the greatest common factor from these two terms.
Mm-hmm.
And you don't need to factor out anything from that. But when you write this result, you can now factor out a 2a minus 1. So what does that become? 18. What do we end up with?
5.
Start
no, hold on.
Start with what you're going to factor out.
You end up with 2a plus 1? Or is it just minus 1?
These are both 2q minus 1. That's a 2q minus 1, and that's a 2q minus 1.
Okay.
So that's what we factor out. And then what are we left with when we divide both of these terms by 2q minus 1?
5qt.
Actually, 5q plus 1.
Plus 1?
Yeah, hold on a second here. We needed to factor out a t from this. So there's an intermediate step here. Let's go back a step here. Let me write the whole thing. In other words, this is one level more difficult than the previous problem. We're still going to group. So I'm going to factor out a q from that, giving me, I'm sorry, a 5q from that, giving me 2q minus 1.
Mm-hmm.
And from this group, we're going to factor out a t,
Yep.
leaving 2q minus 1. Now is where we can factor out the binomial. So that's 2q minus 1. And what's left over?
5q plus t.
Right. This step you have written here needs a t. Oh, that is a t. I took that as a plus sign.
Yeah, I forgot a plus sign.
You need the plus sign, especially when they're going to use variables like t.
Yeah.
T, Q, and G might be the worst variables ever chosen. Because T, it gets easily mixed up with the plus sign, and boy, sometimes they'll include a Q and a G in the same problem, and it's really crazy.
Yeah.
Okay, so here you factor out a 7, you got difference of cubes left, you need a 7 right in front of this one.
Oh, yeah, that's right, I forgot that.
Okay. This one, you factor out a 3y, and you're left with y cubed plus 8, which is sum of cubes. So you can factor this down one more level. 20. You did a sum of cubes earlier. Where was it? Didn't you? Maybe not.
Yeah. Yeah, we did.
Here's a difference of cubes.
Maybe we did. Maybe we only did difference
Maybe we
of
didn't.
cubes.
You know what the sum of cubes factors to?
Yeah, hold on. Sum of cubes is...
It's the opposite of difference of cubes. In other words, if you know if you know difference of cubes, let's say this was sum, since I can't see the other problem. Let's say I had this. Okay? Well, change the sign on this. In other words, change the sign on that, and change the sign on the other.
Mm-hmm.
That's all there is to doing sum of cubes.
Okay. So it's just sign flipping is all it is.
Exactly. Always use the same sign here as your thing is. And then this sign of the middle term is always opposite this.
Yeah, we were taught that it goes opposite, or yeah, no, same, opposite, and then same again, or always plus.
Right. Always plus on this third term.
Yeah.
All right. Number 21. Let's see. What is that? We factored out an x to leave 5 plus 7.
Y.
5 plus y, okay. And minus, and you factored out a 3, but notice one thing you didn't do. If you remultiply these together, what do you get?
Negative 3y plus 15, not minus.
Right, so this has to be a plus.
Yeah.
And it makes sense that it would be a plus, because only if it's a plus can I then factor out 5 plus y. See that?
Yeah.
So what's the final answer? Oops, hold on. What's left over after you factor out a y plus 5? Remember, this is a y.
X minus 3.
You got it. Okay, looks like you're in good shape on these. You didn't really...
Do you want to do a couple extra practice ones?
Yeah, we have 4 minutes. and normally I don't mind going over, but when I have a session at 8, I can't go over. So, but go ahead and read one, and we'll do it.
Do you have any you can make up like on the spot?
Well, I have to pull my book out, but I've been doing this enough that I know what page to turn to.
All right.
Amazing how many times I've had to do this actually in the last week. It's odd because normally I don't bring the problems to the table, but every time we've run out of ones. Let's do some more standard ones like this one. I guess, I don't know. Let's see how much trouble you have with this one.
Okay.
In other words, this is a more common one. Usually you'll have an equation like this, and if you try to solve this equation, you have to be able to factor that quadratic. So how do we factor this quadratic? What is here and here?
3.
3x and x.
3x and x.
Okay, next step.
And then -5 in that one.
Well, okay, you're jumping ahead of me. Or you might be right. I don't know. Let me just back up a second here. Maybe you don't need practice on these. But anybody that does, I think it's really key to go through step by step how you do these. Okay, my next step is knowing that the signs have to be opposite because of that -15.
Mm-hmm.
So I know it's plus minus or minus plus. I have to account for both.
Mm-hmm.
And I'm looking for factors of 15. I'm going to try 5 and 3 to start with. Does that work? No. That gives me plus 5x minus 9x. So I'll switch them. See if that works. Plus 3x minus 15x. Bingo. Is that what the answer you gave me was?
Yeah.
Now, did you do that in your head?
Yeah.
Really?
Yeah.
So you really do these in your head?
Yeah.
And you're good at them. Okay. There's not many people I know that can do that. You must have a technique that works pretty good. My only technique is to trial and error and try all 4 possibilities.
Yeah.
And I always start with the factors that are closest together. I would never start with 15 and 1 as my first try.
Yeah.
Just because the problems they tend to give factor into factors that are the factors that are closest together, like 3 and 5.
Yeah.
Okay. Well, let's end it with that. Since it's 8 o'clock, but that's pretty good.
All right. Thank you.
Okay, you're welcome. And let's see, we're scheduled to meet Saturday at noon, right?
Yep.
Saturday at noon is all I will do is text to your phone number the meeting ID number.
Okay.
I won't call you, and all you do is double click on that icon, put that meeting ID number in, and we'll be good to go.
All right.
All right. Sounds good. I'll talk to you later, Jackson.
All right. Bye.
Bye-bye.